So, hello there, everyone. Tonight we're going to be doing something a little bit different than working on the electron microscope. Behind me, I've got a Veeco high vacuum leak detector. I believe it's 1970s. Don't have an exact date on it, but seeing as I'm getting a new electron microscope to put in my workshop, I've got to make a little bit of room in the floor, so I've got to tear this thing down. There is some really useful parts in it, though, like the diffusion pump and the valves and the rotary vane pump. So all those are going to be torn out, and I'll be talking about exactly how those things work. So we'll go ahead and get started on that. I just need to let people know that I am live. There we go. Okay, well, let's get going. Make sure I can actually see the chat. See here, if I was like prepared and whatnot, I've done all this beforehand. Okay, so first things first, let's pull the electronics drawer. It's got these, I'll actually get the camera a bit closer here. Get my chair out of the way. Okay, so first things first, we'll go ahead and pull out the electronics drawer. It's got these two little knobs at the top, and then the whole thing kind of slides out. So the way one of these things works is that you're working with high vacuum, like even things like ultra high vacuum, even things like regular O-rings still leak enough to cause you problems because you're trying to get so many air molecules out. An O-ring can't stop leaking, so you got to use like metal on metal seals and knife edges, and it gets kind of crazy. But one of the ways you can find leaks is that helium is relatively small, relatively rare. Relatively rare in our atmosphere. So what you can do is spray helium kind of around different areas on the vacuum chamber you're working on. And then whenever you spray it close to one of the areas where there's a leak, more helium will be sucked inside the vacuum. That's useless if you can't detect the helium. So you use a leak detector to do that. And what you do is you ionize the little tiny bit of gas you're sucking through, and then you shoot that gas towards a target. But in between the ion gun that's shooting the gas and the target, there's a big magnet, and that magnet deflects ions of a certain mass to hit the target. And as you spray more helium will be ionized, more helium ions will be turned by that magnet and hit the target. And so you can use that to kind of count how much helium you got in your vacuum. So let's see, where do we want to start on this one? Okay, you know what? I think we're going to leave this. It'll be way easier if I can just take the drawer out. So I got to figure out, where do I do that? Oh, is it really that easy? I think it's really that easy. Okay, cool. There's a little hinge on this side that appears to be the stop for this drawer. Feels like it's on both sides. But before I can pull the whole drawer out, I'm going to need to disconnect this big bundle of wires. Otherwise, it's just going to be kind of awkwardly hanging there. I don't know if there's an easy plug to do that with. Should probably actually point the camera in the right spot. Okay. Let's see. So I've actually taken one of these apart before. So I kind of know what I'm getting into. And I think I'm just going to end up cutting all the wires because I'm not using them for anything. Well, I have to use some of the wires for something. Somebody else is using the analysis tube out of this thing, so I have to make sure I don't damage those particular wires, which will be interesting, to say the least. I think actually we might start tearing high vacuum parts out first. But it'd be so much easier if I could just find a good way of getting the drawer without having to sit there with screw terminals for... Wow. Actually, you know what? I've got a drill. We'll do the screw terminals. That'll be easy. Screw terminals and wire snips. What can go wrong? Yeah, we'll just cut it all. Okay, I'm going to grab a big pair of wire cutters. Actually, I might just grab a pair of bolt cutters. I think the bolt cutters will work for this. Yeah, this closed down close enough. Completely overpowered pair of bolt cutters. Okay. This is also because I couldn't find the wire cutters very fast. This is actually working fairly well. Okay. I really should just find my wire cutters, but this isn't working too horribly. Okay, so that one's free. Thank you, Noah. I'm sure that'd be a great soundtrack for this. Oh, you know, I bet I know where my wire cutters are. I getting some tools packed up tonight. Tomorrow, I have to go get a electron microscope ready for transport, which will be interesting to say the least. Okay, these are actually working worse than the bolt cutters. Wow, the wire cutters are working way worse than the bolt cutters. Okay, back to the bolt cutters. And then this wire is so old and everything in here is so crusty. This is not part of this thing I'm willing to save. And the electronics on this thing are just ancient. I mean, like, there's capacitors that have cardboard surrounding them, and it's like, no, we're not going to try to refurbish this part. Okay, use the wire cutters to last a little bit. Sweet, so that's free. Let's see here. So I need to unscrew that right there. And feel free to ask any questions. So for those of you who just joined us, I got a high vacuum leak detector here. Currently dropping my screwdriver, but before I was dropping my screwdriver, I was getting this big drawer out the front, so I got some more room to access everything. And because I don't feel like, first of all, these electronics are never going to work again. Second of all, I don't really feel like undoing all of those screw terminals and just dealing with that mess, so I just use bolt cutters to cut that open. And we're going to take this screw off, which will release this plate. There's a bundle of wires right there. Just cut that off. And that should free up all the wires off this drawer. So I can go around back and pull those out. Oh, there's two more wires. Where did those go? Okay, that's a high voltage something. We'll ground that to frame. Okay. And cut that. Okay, now that should be all the wires. There we go. Okay. Now that I got all the wires out, I should be able to pull the electronics drawer out completely. But we'll see about that. Okay, so this side's coming out freely. Oh, there's another stop up there. Okay, so there's a hinge down there, and there's another hinged piece right there that I don't want to... So that's where... Okay. There we go. Oh, it's heavy. Okay, the wheel's stuck now. Wheel came unstuck very quickly. Okay. Oh, geez, there's some iron in this thing. Okay. So this is the back side of the electronics drawer. Let me change exposure on the camera real quick. And move a window so I can actually see what I'm framing when I'm down there. Okay. So this is the back side of the electronics drawer. So I got a bunch of transformers and vacuum tubes. Go ahead and pull a tube off here. Come on, there we go. Let's see, RCA electron tube. Oh, that's beautiful. I'll do some macro focus on a whole bunch of these. Just a second, or a couple of these. Cornell Dublier, a couple of big transformers. So this has got a couple of different high voltage supplies. I think it only goes up to 2,000 or 3,000 volts, if memory serves. You can just tell how old a lot of this stuff is, just based on the design. All this wire round post and crazy old resistors, and I don't know if that's a indicator or a vacuum tube down there. I'll have to look at that little component. What else have we got? Just not much going on there. I mean, it's really just throw some voltage at it, do some counts. I got the switches and indicator lights up there. Got a vacuum gauge. That's the vacuum gauge. It's just another gauge. Gauges are a little bit beat up, so I'm not sure they're really worth saving, but I'm not really going after the same for electronics. They're all so old, and there's nothing really, truly unique in here, except some of the tubes, maybe. Okay, a high voltage recidifier. That makes sense. Yeah, that would. The contacts are pretty small for that. Yeah, I don't know what type of high voltage supply it is. It is DC, so it's gonna be recidified somehow. Yeah. Okay. Well, now that we got that off, I'm actually gonna move the electronics drawer kind of a bit more out of the way than it currently is. You want new Star Trek sound effects on the new JSM? Okay, let's see, what was that? That was loud. Had the electronics drawer back there. Oh, jeez. Okay. All the tracks, so it'd be an interesting project trying to get be quite a bit of work to go through each button and send that to a microcontroller. Just gonna get a light moved over here so I can actually see what's going on inside there. See, I'll shorten this light a bit. Get a bit closer in there. Okay, there we go. Hopefully we can see what's going on inside there now. So, quick tour. On the top here, this is where you put your device under test. Just about knocked that vacuum tube over. On the top here, this is where you put the device under test. Here, we'll go shaky cam for this. So there's a input right there. Oh, dropping O-rings everywhere. And then that input comes down here through this standpipe along here. Got a vacuum pressure gauge right there. I think that's one. Yeah, that is one. And then so this entire manifold right here is roughed down with a really big vacuum pump that used to be mounted in the back there, but that big vacuum pump wasn't included in this unit, so it's been adapted somewhere else, I'm sure. And then what happens is through this piece of pipe right here and through this valve, some of the air molecules that are in this roughed down, let's say probably a 50 micron vacuum, are then pulled in through this throttle valve right here, and we'll talk about how the throttle valve works, into this cold trap, and then through this diffusion pump, and then this diffusion pump is backed by this roughing pump. So this is operating at a lot higher vacuum through here. And then what happened is the analysis tube would take some of the gas off from this cold trap and accelerate. But you'll notice that the analysis tube is long gone. I got some photos of it. It's currently being used in another device elsewhere, and that was taken off a couple months ago before I even knew I was going to do a stream about this. But I will show you the photos of the analysis tube now, so we can talk a little bit more about how that works. So all I got to do here is pull the photo up, and then hit this button there, and then hit that button, and there we go. So this is what the analysis tube looked like. So this flange right here is what mounted the tube up to that cold trap and leak detector. And then on this side, we've got a ion gun. So it's basically it's a heater and a high voltage source. And so what happens is that heater, and the combination of the heater and the high voltage ionizes the gas, so it takes off that electron, so it gives the gas a positive charge. And with that negative high voltage is accelerated this way, that way down the tube. And as this is accelerated down the tube, it passes by this magnet right there. So that magnet, you can look at it right there, it's called a analysis magnet. And what that does is it's tuned to bend things of a certain mass around this corner. So it's very similar to a mass spectrometer. In fact, it basically is a mass spectrometer. And as it bends it around the corner, only the helium gas will make it to the end down here, and then at the end there's basically a Faraday cup, and so a Faraday cup is kind of something that just looks at the net change in charge, or it basically counts the ions that hit the Faraday cup, and so by counting the ions that hit it every second or so, so you get a rate, you can see kind of how much gas is leaking into the system, and using that you can determine, okay, where is this leak coming from? So that's the analysis tube, and we'll head back to the webcam now as we start to actually tear into some components on this thing. Okay, so let's see here. Where else can we start looking at? What do we want to pull off, actually? You know, I think what we'll do is actually take this wooden top off, because that'll make just everything easier to access. So I'm gonna move some tools around here. I'll raise the camera up. So start off with, gotta pull this thing all the way off. Save that O-ring. And then this is kind of a ring right here. Okay, so this comes off, as it should. Come on. Might need to get something a bit bigger to do that with. Let's see, where's my big, oh, I want my big vise. Are they here? They are here. Sweet. Let's see, I'll get those set up to grab this. Yes, I'm going to scratch it. No, I don't care. There we go. So now that can then very slowly come off. Okay, so that's off. Now there's, I believe, 4 Phillips screws on the bottom of this that are going to have to be pulled. Okay, so let's see, screw here. Those are big too. And screw here. It's just kind of a pain to get to. That's okay. If anybody's got any questions, feel free to ask them in the YouTube chat. If you feel like I haven't explained something clearly, this should be the last screw on the wood. Yep. Okay, so that's the top. So I don't think I explained how the cold trap worked. Basically, here's the other part of the cold trap. You fill this thing up with liquid nitrogen through the top, and then as air you fill this thing up with liquid nitrogen at the top, and then as air molecules collide with it, it's cooled down, and so it becomes a bit denser, and it's easier for the diffusion pump to pump it then. So this is normally slid in right there in the system. So it's mounted right above the diffusion pump. And cold traps are kind of a cheating way, well, sort of a cheating way, I guess, kind of getting a system to high vacuum without having to have as big of a, or as good of a vacuum pump. Let's see here. What do we want to do next? Maybe the diffusion pump stuff? Drop that whole thing? That looks like kind of a pain. Let's see, it's going to be easier to get first. The roughing pump or the diffusion pump? Hopefully this roughing pump's easier to get out to. Choices. Lots of choices. I think we'll drop the diffusion pump and cold trap first. Okay, so what's it going to take to do that? We're going to take off these hose clamps down there. And then figure out what's next. Yeah, we'll do the hose. We'll start with the hose clamps and then just go from there. We'll figure it out as we go. It'll be fine, right? It's not like I can break this thing any more than it already is. I'm looking for a very specific pair of pliers right now. And I'm not seeing them, and that's concerning because it will make this much easier than the pliers I'm currently holding. These will probably work. What I'm hoping to salvage, most of the high vacuum parts. So the pump and the valves and the diffusion pump. And I might use the cold trap for something else besides the cold trap at some point. Yeah, do you have any pliers for that one? Just kind of twist that off. Come on. You can do it. Okay, so that's off. It's quite a big piece. So I gotta disconnect it from this valve right here. So that's just a couple of nuts. I may need to actually go find the correct size wrench to do this. Is there either a crescent wrench, or an adjustable, or a left-handed nut rounder? Because these things just tend to round these nuts off. We'll come in a bit more. Last one's always the hardest because as the O-ring kind of starts to expand, it keeps putting tension on it, so you can't just take it off with your fingers after you break it free. And access to this one's pretty horrible too. Probably should not have saved this one for last. There we go, now it's free. Okay, so that'll come off when you need it to. Now, I think we just gotta drop the whole thing. I'll have to take that off. That was hard. I'm gonna glove up real quick. There's a lot of dust in this thing. Just... I'm gonna just wipe my hands off real quick. Keep a bottle and a rag out here just for this sort of thing. Yeah, this thing had a cooling fan on the back that just kept on sucking dust in as long as it was plugged in. And I'm sure this thing was plugged in for just years and years and years, judging by how much dust is inside of it. So it's probably better to be gloved up for this. Okay, now we got gloves. So that okay, so that should be it for the diffusion pump stack now. I have to figure out how to get those bolts off. Let's see how do I want to do this. Where's, I'm just gonna pull. I'm gonna actually pull that whole valve off. Just a couple of socket head screws right there, and that'll get the bolts that stick through clear of the diffusion pump stack. See, is that the right size to get lucky? Nope, that's not the right size. I don't know if this is imperial or metric. I don't remember. And of course, one of my metric Allen keys that I'm betting is the right size is not currently with the set, so I was using it for something. Can't tell you what I was using it for or where exactly I used it last, but maybe that's the right size. That's not the right size. Okay, yeah, I'm pretty sure that's metric. Where could I have put this Allen key? Trying to think back to what I would have used it for. I know I used it for something on the electron microscope. In fact, I'm fairly certain I used it yesterday. Probably putting a door seal on or something. That's the size it is. I have a bad habit of just setting these down and I'm done with them. Not always properly putting them away. Which, on occasion, leaves me in times like this. I'll try the other sizes, but I don't think they're correct. Yeah, that's almost right. That's gonna be way too big. Yeah. So I gotta find my 8mm. Or not my 8mm, my 3.5, I believe. I have a tiny shop too. Usually I don't lose things like this. Wow, what did I do with this thing? Huh. Okay, well, we'll figure out a different way of doing this. Pliers. We'll try it with pliers. Yeah, pliers will work just fine. Just take a little bit longer is all. There's one bolt, or cap head screw technically. Cap head machine screw if you want to be really precise. Okay, we'll leave that one for last because that's easy to access. So do the ones that are harder to access in the meantime. That plug, come on, come out. How do you come out? Oh, twist out. There we go. Get that cable harness out of the way. These are not all the same screws in here, which is interesting. So apparently this has been serviced before. You know, even if I had my socket set, it wouldn't reach in here because of this 90-degree piece of copper pipe. Yeah, clearance on this thing is just non-existent. Okay, it's coming, just slowly. Yeah, I'm glad I'm not doing this on last. That'd just take forever. There we go. This is not the correct socket screw. And this is not the correct Allen key, but it does just barely engage. So I knew I couldn't torque on it, but I could use it just to do that once I took it off all the way. Okay, let's see. How does this... Wow. Okay, so this is cool. There's not enough clearance here to pull this thing out. So as you start to... See, I'm limited by USB cable right now. So as I start to pull this thing out, it starts to hit this pipe right there. So I'm going to kind of have to do a bit of a dance. As I pull this off, I'm going to have to slide it over a bit because I can't get this far enough away, and this is going to be interesting. Let's see. So I think for now I'm just going to loosen all 4 of these. Didn't mean to take that all the way off. Okay, let's see here. So this is about to come off now. So we'll just take off all but 2 bolts. You know what, Noah? I'm fairly certain, for some odd reason, that you also have got another, or parts from another cannibalized leak detector that looks very, very similar to this one, and I don't know why I say that, but no, I'm sure they were all pretty much the same back then. Okay, just one more left to go. This thing's gonna be a pain to move out of here. Okay, let me make sure that the bottom of this diffusion pump's flat. Oh, is it not flat? Great, this is gonna suck. Okay, I'll just lay it on its side and deal with the oil later. Yeah, because there's still gonna be oil in it, I bet. Okay, so I gotta to simultaneously take all the weight off this thing and unbolt it. Okay, it's unbolted, so I've got all of the weight of it, and I gotta figure out how to get this stupid thing out. So now it's literally resting on that piece, which isn't good. Do I not have the clearance to do this? Will it just not come off? Great. It's heavier than it looks, I promise you that. There's just not the clearance there to pull this off. Okay, going to have to single-handedly put a bolt back in. So this is going to be interesting. Okay, that's back in. Okay, revised plan. There's 4 socket head screws on the rear side of the valve that will let me pull that piece of copper pipe off that was causing the conflict earlier. My Veeco is different than the Veeco we worked on. Found the Allen key. It was on the lower shelf of a cart. Now this one's built a bit differently. The one we had worked on was cannibalized significantly more than this one. Not just modified, I'd say, not exactly cannibalized, but not different model, just one that hadn't had its analysis tube pulled out and replaced with a big vacuum port on the side of it. Got it. Hey, they got Vitone in here. They did a good job. So now, there we go. Okay, let's take for this knob to come off. Really skinny Allen key. There we go. Huh, it's loose. Come on. Oh, it's like stuck on something. There we go. Oh, that shaft's been beat up on before. Wow. We'll talk about this valve in a little bit. I want to get that diffusion pump dropped first. Oh, something's caught somewhere. Oh, it's the plug on the blower for the cooling on the diffusion pump. Okay, that's free. Okay. This is not an insignificant piece of copper. Come on, loosen up. There we go. Well, that's the cold shop diffusion valve ion pump / ion gauge assembly. That's not insignificant. That's, I don't know, what is it, 50 pounds or so right there? That's fun. Now let's figure out a place to lean it. See if it'll sit against the garage door. Okay, let's talk about that valve now. Okay, I see how it works. Okay, so this is the valve. Let me change the focus real quick and get some more light over here. Gonna go a bit more macro than I am right now. Not that much macro. We'll go that much macro. Okay, so here's one of the valves, and they're all pretty much the same. They've got this plunger on the inside that, as you turn, moves in and out. And what happens is because this is high vacuum, rotary seals and linear seals don't make really great vacuum seals. So if you see in there, there's kind of some copper bellows. So when you're doing this linear and rotary motion, you're not actually having any motion feed through, because there's just those bellows that are expanding and contracting. And then on the inside there, if I pull this all the way back, you'll be able to see a, it might be a bit dark, let me grab a flashlight. You'll be able to see an O-ring. Let's see, there we go, an O-ring side of there. And so once you push this thing in all the way, that O-ring is what makes the kind of the perfect seal in there. And so this is a throttling valve. So it's designed to be able to kind of control the gas flow in a bit more of a precise manner. So you'll see it's also got kind of the plunger goes all the way through that hole and has got some kind of holes in the copper that is the plunger. And that just gives you a little bit more control over the throttling nature of this. And so you can see it's got these two flat faces, and those two flat faces are what makes the vacuum seal. So an O-ring gets pushed up against that. And that's for the big two throttling valves on this thing. That's how those work. And the other two are gate valves, and I'll show one of those off in a bit once I get it pulled out. Yeah, so this, we'll set this back over here. And so we'll change the focus back. Okay, so what have we got left? We've got the roughing pump, got a power supply, which I don't really feel like touching at all, and got some couple more vacuum components. Let's see here. Wow, this is a pain last time. I think we'll just get this valve out for now so I can talk about that valve. And of course, it's a different size Allen key than all the ones I've been using before. Is this an Imperial? What? I'm going to be annoyed if they mixed Imperial on this thing. Yep, they did. So this has both Imperial and metric pieces on it. Which makes no sense. Once again, if you've got any questions, feel free to ask them in the YouTube chat. There's the valve. Huh. That's interesting. Probably doing this on camera. Okay, so here's the valve. Twisting it. Nope, that came off. Okay. So it's an electromagnetically driven valve, so a solenoid valve. So that's the big coil right there. There's a nut right there, so we pull that nut off. That retaining clip probably comes off. And that whole coil comes off. And this thing just operates at 120 volts AC. So supply voltage there, and I bet it's normally closed, if I had to guess, seeing as it's closed right now. But is there an easy way to actuate this thing? I bet this whole thing's actually vacuum sealed, so I don't really want to open it up. But it's pretty simple. Wait, really? No, it's not that good. Let's go all the way through. Yeah, so it's pretty simple. There's a, in this copper piece down here, there's just a plunger that goes up and down. And if it's up, it's open. If it's down, it's closed. And then there's an O-ring seal on both sides of the plunger that it engages with. And then the electromagnet is what can pull it up. And then it's got a spring to push it back down. And that way it always stays, that way if anything goes wrong with the power, the thing automatically shuts everything off. So I'll go ahead and put that back together now. Yeah, those wires are a bit crusty. I'm not sure I'll be using this as a valve anytime soon. Actually, no, they're not too bad. Okay, next comes the retaining clip. Then the nut. Inertia works well to open it? I'll have to try that. let's see if we can get it closed up properly now. Oh, gotta be tightened down a bit further. Okay. Come on. Okay. There we go. Now let's get that nut on top. I can see it moving, but I don't think the camera can see it moving. Yeah, I can see it dropping down, but it's spring actuated, so it just pops right back up. But yeah, basically it's just a gate in there. That's why it's called a gate valve, so that gate moves up and down. Okay, let's see here. Where do we want to move on to from here? Can I force the gate down by hand? Can I move it a bit? Yeah. Okay, so that's how the gate valve works. Actually, I might just be able to stick it out. There's a little hole. I might be able to... Okay, there we go. I can kind of show you this now. So you can see it's just that gate that moves up and down. And the O-ring isn't quite centering in place. So I think this has got a little bit of work that needs to be done before it's used again. That's okay. That won't be too bad. I wonder if there's bellows in there. It might be. It's only on the roughing side though, not the high vacuum side. So I wouldn't be surprised if it was just a linear motion feed through instead of bellows, but you never know. Well, I mean, you can know. You just gotta open it up. Okay, let's see here. Now, what do I want to do? Looking at this piece of copper right here, I just don't think I'm ever going to use that piece of copper for anything. Yeah, it's got flanges on it though. I should probably keep the flanges at least. You can always turn new ones though, but we'll pull it for now. Let's see here. So I'm gonna have to... Okay. So I remember this being challenging on the other one I just took apart already. Oh, right, of course, it's just magnetic, that's all. Yeah, that's actually how the magnetic valves on my SEM work. I don't know why I didn't remember that. That's the wrong screwdriver for that job. It's a better one. So I'm going to take this all off but one. And then pull this. take the nuts off instead of the screws. Those are pretty tight on there. Okay, back to the screwdriver. And then you can see it all what I'm doing. Yeah, tell me these sort of things. Okay, I think I've got a screwdriver that'll do this better. I think I have a snap-on that's got a, it's not the, it's Phillips, not Common. Huh, this just got interesting. Very, very interesting. Let's see if we can find the right... Do I even have a wrench that small? Okay, so bigger than 8 millimeters. Bigger than 7 millimeters. Might be 8 millimeters. We'll just bring 9 with us. Okay, bigger than 8. Really, bigger than 9? Yeah, bigger than 9. Okay. I know I've got an adjustable. It's just for the clearances I've got, I'd rather use just a fixed size. But I don't think I have a 10. Rather than 11. I think 10 is one of the sizes I'm missing. Yep, it's a 10. Okay, time to use the adjustable. Okay. Okay, there's one. There's a rounded one. Okay, there's two. And for the third, come on, don't round on me. These are really soft. Doesn't help that it's just spinning. That's not in good shape, jeez. The threads on this one feel damaged. Gonna have to fight it the whole way. Oh, you can hear it too. There we go. Nope, not there yet. There we go. Cool, those are separate. Now it should just be a matter of taking off the one screw on this side. Okay, there we go. Got that whole piece off. If there's ever anything that any of you want to see in more detail, just let me know and I'll grab the piece and show it closer on the camera. Though I am trying to show all the interesting stuff on the camera. Okay, 1.5 more screws on this side, and this will be out. And then we're going to move on to detaching the roughing pump. Okay, one more screw. What the heck? Okay, oh, there's one more. There we go. And here's the other piece of this manifold. There we go. So a couple more flanges to play with. And I think it's time to move on to the roughing pump, which is not going to be fun. I can tell you that already. Oh gosh, this thing's nasty to take off. It's made worse by the fact that I don't have the tool with me to do it like I did last time. Okay. So this roughing pump is used to back the diffusion pump. The diffusion pump is what it uses boiling oil to molecularly knock air molecules down deeper into the diffusion pump. But I mean that oil can only really work in a low to high vacuum range. And so to get to that low vacuum range, you need to use the mechanical roughing pump. Now, this roughing pump's basically got these chambers on the inside that it changes the volume of the chamber, so it expands the volume, closes off a valve, sort of, and then decreases the volume to expel all that air, but that doesn't work at high vacuum. So you use both these pumps, but getting this roughing pump out of this particular unit is quite challenging because it's mounted on these vibrational isolators. And vibrational isolators have got an encased nut inside of them, or captive nut. The problem is that this captive nut, it spins because the rubber's old. So it's really, really hard just to take the screws out of the isolating feet. So last time I did this, I cut it open, and I just cut it open using a sawzall, a reciprocating saw, but I don't have that with me right now. So I've got to figure out another way of getting this pump off of those isolators. I've got a wood saw that might saw through the rubber fairly nicely. Let's see here. What tool? I could try the bolt cutters. That'd be interesting. I bet they just got such a narrow opening is the issue. I could just light it on fire and call it good. Just burn the rubber off, but I don't think that's a great idea. Actually, I think that's an amazing idea, but I'm not going to do it. Let's see here. Anybody got any ideas? Let me know in the comments. These are a different style than the other one I took apart. Yeah. That's weird. Okay, I'll try it, because this is a different style, I might get lucky. Wow, that's nasty under there, that dust, jeez, that's thick. Let's move this thing out of the way. That. And just go for it. We'll use an adjustable probably. Make it a bit brighter so that everyone can see down in there. I should have done that sooner. It's not going to go how I want it to. I can already tell. So I might have to pull the wheel off this pump. Or the pulley. Now that's not fun. It's the opposite of fun. Okay, let's start with that one over there. That one over there, if I can't take that one off, I'm gonna have to cut it. I'm more confident that I can get this one off because the nuts are on both sides in this one than I am that I can get that other one off. Now, this one's actually coming out pretty easy. That's good. Okay, so that's one off. Where are these other ones mounted? See, I'm going to grab a second adjustable wrench and work on this one. Actually, let's check the back out real quick. Make sure I'm not setting myself up for failure here. No, I'm not. Okay, cool. This looks like it might be doable. Okay, another adjustable wrench is going to be right here. Okay, cool. There we go. Come on. Get it on there. Okay. It's a lock nut on there. Night lock. So that's going to make this all the more fun. I free? Nope, not free. Come on, stop being such a big pain. Oh, it's free. Okay, so that's one half of that. Now the other side is a flat head. And it's in. Gosh, I think I gotta take the pump's pulley off. Yeah. That motor's got some inertia to it. Oh, she's really free spinning. Nice. Well, the motor's still in good shape. Well, I mean, okay. Potentially, it's still in good shape. Okay, so I know that these Welches are Imperial. Wait, is this one not? Oh, that's just really rounded out. Okay, we'll go one size up to the metric size. Because that one's been rounded so much. Yeah, even that's loose. This is going to be a pain. Okay, let's see here. Something I can pry with. There we go. There we go. No, not quite. Sweet. So that's the pulley. This is a Welch 1300, if any of you are curious. Pretty good vacuum pump. This is an older style, so you're not going to find it. If you look it up online, you probably won't see this exact one. If you're really curious, it's the generation where they had the funnel-shaped sight glasses on it. I don't want to do this part. I really don't want to have to pull all 4 bolts off this pump just to get the screw off. Need a bigger screwdriver. It's the biggest screwdriver I have. think my really big one's inside right now. I don't really want to go get it. Oh, that looks to be about the right size. That'll probably do. There we go. Okay, well, that should be free. There we go. Yeah, it's free. Just a bit sticky is all. Okay, now same thing on the back side. Oh, but there's an electrical box right over top of the screws. That's lovely. Okay, gotta pull that box off. This is just a standard outlet. Plug some devices inside this thing into it. But underneath this outlet is where these screws to the vibration isolator are. Thus, the outlet's got to come off. Okay, 2 more screws on the bottom of this box, and I will be good to pull this out. Yeah, they really could have placed this thing better, I think. Come on, jeez. What are the screws do they use in this thing? Okay, that's both screws. Why isn't it coming? Oh, it's just stuck because of oil. Okay, so 2 more screws under that are actually attached to the vibration isolation feet. So I gotta get those now. Okay, so let's see. Big screwdriver and adjustable wrench should be enough to pull that off. And I got 2 more behind the pump. I'll worry about those when I get to it. Okay, where'd my big adjustable wrench go? Let's see here. Where is my wrench? Oh, right there. Come on. Okay, that's 1 down. On to the second one. Come on. Some downward force just to get this one broken free. Wow, this thing's hard. There we go. Nope, not done yet. Just about there, though. Okay, I think we're free now. Yeah, now we're free. Sweet, now there's 2 more of these screws behind the big rotary pump, and of course one of them is right underneath the plate on that. That sucks. One of them is going to be easy, one of them is not. Ouch, this one's worse than the last. Okay, it's getting there though. There, broken free at least. Okay, now that'll come off, and I got one more left in there, and I don't know how I'm going to get it because my current screwdriver will not fit because half of it's covered by a vacuum pump I do not want to take off. Let's see here. How am I going to get this screw off now? The problem is I take the sorry, it's just a rotary pump right there. I take the rotary pump off normally and get to the screw, but I can't access all 4 bolts in the rotary pump because the rotary pump is right up against that right hand piece of sheet metal. So I guess I can try just getting part of my screwdriver into that slot on the screw, and then turning it from the bottom with the adjustable wrench. Yeah, I'll try that out. Try a slightly smaller screwdriver too. Yeah, we'll try a slightly smaller screwdriver first. Okay, I think this might work. Or if I can just get this turned about 90 degrees, I can get the big screwdriver in. There we go. Okay, this is coming. Okay, it's free. Yep, whole pump is free. Sweet. Now the problem with this pump is, of course, that it's really, really heavy. Not as heavy as the vacuum pump on my SEM, but still heavy, still annoying to move. I think that's pretty much it. I think that's all the parts I want out of this thing. Yeah. I'll tell you what, I'll talk about the diffusion pump real quick and how the diffusion pump works. And then I think I'm going to call it a stream there. Because I don't think... I can leave that in there for now. Instead of talking about the diffusion pump that's actually on this particular leak detector, I'm going to talk about the one that's on my SEM, because it's easier to show you. Because, well, first of all, it's smaller, so I can just hold it in my hand. Second of all, you can actually take it apart, because this one is kind of sealed up inside. It's really annoying to take apart. So this is what most diffusion pumps kind of look like. Cylinder, water cooled, and at the bottom there's a heater cartridge. That heater boils oil and sends that boiling oil up what's called the Christmas tree, or they're actually known as the baffles, but they're called a Christmas tree. And that boiling oil gets sent up inside of this thing, and then the vanes on these baffles direct the oil downwards, and the force of that oil being directed downwards, that vaporized oil, because it's boiled off, so it's vapor now, those oil vapors collide with air molecules. And as they collide with air molecules, they knock the air molecules down. So you get a higher pressure of air coming out the bottom of the pump than you've got coming in the top of the pump. And so you can use this to get down to a higher vacuum by getting more air molecules out than a normal, or than a roughing pump or rotary pump can do. And you've got to water cool the top part of that, because you only want the oil to be heated up on the bottom. You actually want the oil to condense once it hits the walls of this thing. So you got to keep these water cooled. So this is what the water chiller on my current SEM is for. All my water chiller does is keeps the top part of this thing cold. On my new SEM, the JSM35C, the water chiller actually cools some of the electronics in addition to keeping the diffusion pump like this cold. And the diffusion pump on my new SEM is about twice the size as this diffusion pump, just to give you an idea. So it'll pump down a lot faster. This is a thermal cutoff switch. So it just shuts off if the water supply turns off. This button pops out, or is kind of forced out more, and just turns the diffusion pump off, and that way you don't dump a bunch of heat where there shouldn't be a bunch of heat in the microscope. Because that's bad for things, it turns out. O-rings that aren't designed to get hot don't like getting hot very much. So that's the diffusion pump. And the other one, instead of being water cooled, is air cooled, so those baffles on it were for. But you can't take apart the other one nearly as easily as you can take apart this one. Tokyo Vacuum Machinery. They're not around anymore. Yeah, this was probably built in 1978, 77 or 78 is when I had to guess this was built. But yeah, so that's how the diffusion pump works. If you have any questions about that, let me know. They're pretty common in high vacuum, though they're being replaced by other types of vacuum pumps, like turbomolecular pumps, or not cryo pumps. Pretty much they've been replaced by turbomolecular pumps, and those are just another molecular type of high vacuum pump. If anybody's got anything else they want to see on this, any other parts they want a close-up of, or anything else they want an explanation of, let me know in the chat. But other than that, I think I'm going to call it a stream. I've got to get ready tonight, got to get my tools together for getting that microscope powered up tomorrow, because I got to get the microscope on, got to get it to atmosphere so I can take the detectors off. That's going to be a whole big deal. And then Friday, I got the rental truck, and I'll be driving up there and loading into the back of the truck and bringing it back down here. So follow me on Twitter at Nanographs if you want to see photos of that. I'll be posting them as it happens. And then, of course, there'll be videos here and live streams here once I get it back to my shop. Give anybody else a bit more time to ask a question if they got it. They got one? Well, hearing none, I am going to go ahead and call that a stream. I want to thank you all for watching. Hope you found it entertaining. And see everyone later.